Okay, so I'm going to give you a little, well, probably a different perspective, but a similar perspective. I'm going to come back to the initial, a lot to the initial side that Mike started with about where do students, young professionals, learn concrete constructability, okay? And those two words are tied together there with that slash on purpose, because at our program where I come from, the Del Webb School of Construction at Arizona State, we treat our students as young professionals from the very get-go. And I think we're a little unusual in that respect because, and that'll be a part of the topic that we're going to talk about today, about we look at you guys as students. So again, I'm going to ask again, where are the students out there? All right, awesome. And how many students have some field experience? Mike already said that. All right, all right. How many engineering students do we have in the room? Yeah, see? And I'm going to say that's not enough right now. All right, because I know we have more civil engineering students here than probably any other major. Where are all your compatriots, guys? Because they need to be in this room. And unfortunately, they're not. And that's kind of the topic of what we're going to talk about. So you've seen this slide already. This is what ACI 134 says about constructability, and it's the effective, timely integration of a lot of good flowery language there. I love it. With the goal of optimizing time, safety, and cost while maintaining quality. All right, now I'll throw that up there specifically in the color to kind of highlight that. All right. So constructability involves time, safety, cost, and quality. That's a pretty broad range of stuff for any university to cover. So when I got this topic from Keela and I started looking, okay, how do we teach this here at ASU? And we really don't. You can't find a single course at ASU in our program that says constructability. You can't find a class in any one of our courses, I don't think. I didn't look at every one, I'll be honest with you. But you can't find a class that's entitled Constructability. Yet it's going to be woven into every class in much the same way that we teach ethics across the curriculum, because ethics shows up everywhere. And what we find is, go back to look at time, quality, cost. All those things are woven through any construction program, you know, and unfortunately where they're not as woven through civil engineering programs for you guys on the civil side, and I think that's part of our issue, but we have to teach that constructability everywhere where it shows up, whether it's an estimating class or a scheduling class, or in my class, I teach it in structures. I have a structures class where the whole idea is to educate our construction management students so they can hold a intelligent conversation with the structural engineer on the job. Just like Mike was talking about going out there and talking to the structural engineer, I want to make sure that our guys, when they go out the door, know that that structural engineer is not the enemy, all right? But he's another team member. Okay, how many structural engineers in the room? All right, excellent. I'm not going to throw any rocks at you guys, well, maybe a few. And the reason I'll throw a few at that, because, I mean, I got 3 of these engineering degrees, came out with, my first degrees were in mechanical engineering, passed all those classes, graduated, didn't jump off the ledge like Melissa did, but I think I probably have a picture of me somewhere back in those days, but they were with Polaroids, the kind that slid out of the machine after you took a picture. That's how long ago that was. But I passed every one of those classes, and I couldn't tell you what an engineer did after I graduated. All right? I had no idea. Now, you structural engineers in the room, when you graduated, let's be honest, did you know what a structural engineer did? I'm going to guess and say you didn't. Why? Because we don't teach that in engineering. And I went back and got a PhD. The connection is kind of funny here. Melissa's talking about a gentleman on the screen that had an impact on her life, Ramon Carrasquillo. For those of you that are longtime ACI, you know who that is. Ramon was my supervising professor when I got my PhD. And by that time, I'd already spent 10 years in the construction industry. And so he and I meshed just perfectly because we had a very, very similar attitude of we just got to get this done. There is no black and white. Everything is gray in this industry on that side. And that's one thing you have to understand. And that's, I think, is a challenge we have especially on the engineering side. And we bridge that, I feel, very well, because I got done with my 3 degrees in engineering. I was going to go join academia. I spent my last 3 years teaching civil engineers, all right? And when I got done with that experience, I said, I don't want to do that anymore. I want to go teach on the construction side where I felt like I could make more of an impact, and it was a lot more fun. All the work I had after 20 years in the Army Corps of Engineers was more on the construction side than the engineering side, so that's where I went. So how do we teach that at Del Webb School of Construction, where I come from? We let our faculty incorporate the constructability issues into every class that they teach. And we're very blessed that we have a lot of faculty with a lot of work experience, and I think that is key to making that happen. I mean, we include example problems in different classes. We give students that take the computer applications class, give them a little Navisworks problem where they show a beam running into a duct, and they've got to work out that clash issue, things like that go on. But we take it far beyond that and incorporate into the estimating, into the scheduling, into my structures class that I teach that says, okay, here's something we ran into, and what I reach out to our alums and I say, bring me back issues that you faced. Bring me back problems that you faced with regard to constructability, so I can bring that back into the classroom and show our students these are the things that happen. And I'm going to show you a few examples of how we do that, because what I find is we do, and they bring those ideas back in spades, not only after they're graduated, but even while they're in school. I get them coming back into the classroom and say, hey, I just took a summer internship with Baker, and this is what I saw. And then we can turn that around in the classroom and say, here, watch out for this. And this is, I think, a much more effective way to teach constructability, is with bringing the industry into your room. Bring the industry into your classroom to say, here, show us what you have seen. Now, we benefit at Arizona State University from being located in the 5th largest metropolitan area in the country. So we have lots of industry around us. Not everybody has that advantage. I understand that. But I would encourage everybody in the room, engineers, if you are located near a university, offer to get back in that classroom and help your professors learn that, because I guarantee you, your professors in engineering have not had that experience by and large. And I'm going to throw a huge blanket over a lot of them. That won't apply to everybody, but by and large, our university systems don't serve our students well when it comes to teaching them how the industry works, how our industry works. I had this discussion. I was telling a colleague of mine just Saturday night, all right, about where I was going. It was a Saturday night. I was still in Phoenix. I caught a red eye out here to make the meeting, and I'm at a fundraising event on Saturday night, and I'm talking to a colleague of mine who is an architect, and I'm telling him what I'm going to go talk about, and he's laughing with me about it. He says, "Yeah, because architecture is the same way." He said, I got 25 years in this industry as an architect. Mike, you'll appreciate this. He said, I was 10 years out in the industry. I was a project leader for a major architect in the Phoenix area. And I'm at this meeting on a project, and the contractor and the mechanical engineer are arguing vehemently about an issue. So I'll get over and try to mitigate what's going on, because I'm the lead architect. I'm kind of got to be the guy in charge. And I say, what are you guys arguing about? Oh, we're arguing about the location of a VAV box. Okay, for those of you that don't know, a VAV box is a variable air volume box, part of a HVAC system, okay? It distributes the air from the mains, from the ventilation mains down to the secondary mains that get your air into the rooms, all right? And he says, I got these guys, I said, okay, just tone down the language and let's get this thing solved, all right? He said, and then I went back to my desk and I sat down, I picked up my phone and I Googled VAV box. Because he said, I had no idea what a VAV box did. And there's a guy that's been 8-10 years out in the field, all right? Coming out of college, he didn't understand, didn't know. Okay, so that's a problem. That's a problem with our education system. And I'm gonna throw the big blanket over primarily the architects and engineering communities, because the constructors, in my view, and I'm biased, I'll admit that, we have it right. You guys in the CIM program, you know what I'm talking about. They send you out to the field to learn. We bring the field into you, all right? In our program, everybody has to do 2 summer internships. You cannot graduate from our program without doing 2 summers out in the field. It's a 1-credit class. You have to pay for it, by the way, which students love, right, Blake? Yeah. See, Blake's back. See, he came back. And so you're gone. See, I asked the question, man, I had the question all teed up for you, and you missed it, dude. Just woof, swing and miss. Okay. So, but we embed field trips. We embed faculty to come back in, people to come back in to talk. We invite the industry. We beg the industry to get engaged with us. And unfortunately, we cannot convince, because we're sistered up with civil engineering department in our program. We sit side by side with them from an organizational standpoint, but we might as well be on 2 different planets from a curriculum teaching view, because they will hold the industry off like this and say, we'll teach them what they need to know, and we'll send them out to you, and you can train them to do whatever you want once they graduate. I don't know if your university does it like that. I hope they don't. I hope they are much more inviting. But I know for a fact where we are, that's the way the engineering program does. And I'll bet my alma mater from 150 years ago is probably not that different now, but I have not been back in a while, so I can't really say that. But in general, we need to do a better job on the engineering and the architecture side of inviting the industry in. And how can we do that? By any and all of these things, okay? So, techniques we've learned, and Mike addressed some of these things, and CII has talked about this for a long time. You know, how do we get more engaged in constructability? You know, do we allow that contractor involvement early on? We do that at ASU, construction partnering. We do that at Phoenix, building information modeling. Prefab has done a lot of good for that, with helping us in all those things. We do all that here, but we still have struggle. We still struggle with it. We still have issues. Why? Because the people, in the end, this is a people game. It's by people working with people, all right? And depending on how you were brought up, how are the rules of the game? And if you were brought up, especially through the education program, where this is my role, I tell our students in the structures class I teach, I throw out a slide in one of the first classes, I say, you know, most structural engineers, you know, would tell you there are 3 goals of structural engineering. And you guys in the room, you tell me if I'm wrong. It would be safety, and then it would be aesthetics, and it would be constructability, and something in those areas. Is that a fair assessment? Maybe. But a lot of structural engineers have three goals, and it's safety, and then it's safety, and then it's safety, all right? Because why? Because they know that once that design leaves their hands and goes out, they have no more control over it. And they want to make sure that they can sleep at night. They're human, just like the rest of us. So there can tend to be a not too much focus on those other things, that like Mike was talking about, all right? And those are the things that we want to start to get people to play together nicely in the sandbox, and again, bringing the real world of constructability into those classrooms when you're still a student. that's the only way we're gonna change, I think, get the things that Mike was leaning towards. How do we get more collaboration? Mike said the word collaborate about 14 times, if you remember in the presentation, and that is absolutely key. But that collaboration would go much better if we started that collaboration when they're still students and not waiting till we're getting out. So we would break down that mold of waiting till Mike wouldn't have to hear that conversation with the rod buster after he's been 25 years in the industry, or maybe it was 45, somewhere around there. But anyway, so you know what I'm saying. So we've all seen this in the industry where we got too much steel in there. We can't get the concrete around that. How are you going to get concrete down around that right-hand beam? The left-hand one isn't too bad, but you know, we've all seen that before. And those kind of things, and those will continue to happen if we don't have more discussion of this kind of stuff. I've reached out and I brought in a few examples from our students that have brought constructability issues back to me based on our classroom discussion and our people going out in the field. And I wanted to share a few of them with you. The first one is a grade school that we built in Phoenix about 10 years ago. All right, Monte Vista Grade School. The issue is jointing and subsequent cracking that comes from jointing. Okay, so that was the topic of this one. The backstory, and this is a fascinating backstory, at least I find it anyway. I hope you do too. The contractor was contracted to demolish an existing school and rebuild it from the ground up on the property. Okay, so knock it down and rebuild it. The current school principal, they're in the design phase. This is a CM job, so everybody's in the same boat working together. The current school principal was a student at that school back in the 1960s when it was originally still a school, all right, and they had planted a tree on the property, which is now 40 years old, you know, way up tall. The principal would like to salvage that tree as part of it. So what does the project architect do? He's going to do everything it is possible to satisfy the owner, right? I mean, that's very standard. It's what we do, right? Can't save the tree, all right? There's going to be a building in the way. It's just to work around it, can't save the tree. So what does the contractor decide to do then? All right. So he decides to incorporate the tree into this main sidewalk that walks down the middle, and he's going to do that by making the joints in the concrete sidewalk look like the bark of the tree. You know where I'm going with this now, don't you? Okay. That's what the original design came out looking like. How would you like that, Mike? And I'm not making this up. This was real life. That's what the architect said. Yeah, let's make the joints look just like that. So thankfully, you guys in the CIM program, well, you know, my project engineer on the job, Del Webb graduate, came through the CIM program at Arizona State, back when we were a CIM program before they booted us off the island. Got this young architect by the stacking swivel and said, look, this is not going to work. All right, so recognized the problem, called a meeting of everybody concerned, all the way from the owner all the way down to the concrete finisher, and said, let's do something different. And we came jointly to a plan, pun intended, all right, on how can we make this look a little different? And it ended up looking like that. This thing is about 170 feet long, anywhere from 12 to 15 feet, 20 feet in diameter and width, going all the way down there. And you can see them actually finishing. It was a colored concrete. They recommended let's put some fiber in there to help with that, since there will be the possibility of cracking. And that was it going in. All right. And sadly, 2 years later, at the end of the warranty period, what do you think happened? Even with putting in less joints to make it look a little, you know, it cracked. All right, there was cracking involved. So the contractor, the GC in this case, took it out at his expense, paid the concrete finishing subcontractor, re-put it back in, all right, and they put it back in a similar fashion there, again with some slightly different changes, a little higher dosage rate of fibers and a few other things. but he incurred that cost because he wanted to maintain the relationship with the school district and build more schools. All right, now, so what do we learn here? But this is, and again, this was a situation where the designer wanted to try to please the architect, or wanted to try to please the owner. I mean, it's a situation where they're trying to work that out. It's a people business, but the architect did not understand what they were asking for and what they were trying to do, what it was going to do. But it's the sidewalk is still there. The left-hand picture is 10 years old. The right-hand picture is about 2 weeks old. All right. I want to go back and take a look at that and see. And by the way, there's a lot more concrete in that besides that, none of which cracked besides that sidewalk, because the rest of it was nice square joints like we normally do. All right. So a few lessons there is you got to be careful, and not to mention that, Mike, what does it cost to run a foot of saw cutting? A couple of feet per a couple of dollars per foot, maybe. So by the time you add all that in, you're adding some more cost as well. Not to mention the $20,000 or so it costs to replace all the sidewalk 8 years later. So a couple of other ones. All right, this is another one. This was a post-tensioning failure problem, a little more expensive than the previous one. This was a 3-story luxury apartment in the Phoenix area. It was a post-tension concrete podium with some wood framing above it. Our graduate in this situation was a civil engineer, actually, guys. Civil engineer in this case, employee of the ready-mix producer, so not directly involved in all the issue, but nevertheless got splashed with the cost. They made some changes to the design. You can see, if I can find the, where's my bone? Right there. You've got some, it's not really heavy, but you've got some post-tension beams going in there that where the problem involved. They made some design changes where 2 post-tension beams were combined into one for some reason, and I can't give you much more guidance than that, because when failures occur, you know what happens on a job site, right? Nobody talks. Nobody will tell you anything about going on. So I could not get a lot of information from anybody on this, but that is what, all right, what did I do here? I lost something. I got that one done. Now we're going to go there. That was what the post-tension end of the beam looked like. Yeah, where are my structural engineers? Does that look like a problem in the works here? That looks like there's an awful lot of density there to me. And I got that degree in structural engineering, but I never designed any of this. But I've seen enough of them to say, man, that's pretty heavily, okay? And when they stressed it, that happened, okay? So that's what occurred. Now, that's just a situation where, hard to find out what happened here, because nobody will talk. They did repair that cost, okay? Maybe it was constructability related, maybe it wasn't. Somebody probably should have raised their hand and say, this is an issue with getting in, I would think. But I do know that it cost around $500,000 to fix that one. That was a little more expensive to fix and go back in. So sometime, again, might not have been a constructability issue, but certainly was part of the communications which could have solved that problem had they not done that. All right, let's go back to communications again and constructability related. This one is definitely owner-driven congestion, okay? Mike, we talked about this a little bit in yours as well. There are some columns on a highway bridge, okay, on a freeway bridge in Arizona, all right? 45-foot tall columns. Part of a widening project here in town, in Arizona right now. And the project was mandated by the owner to match the existing columns, which is on the left-hand side. You can see the existing columns. They were cast 40 years ago. It's out in the middle of the desert in Arizona. Why they exactly had to match it is beyond me, but that's what the owner wanted. They wanted it high. And it's interesting, the existing columns were cast in 2 lifts. And it was very clear, you can see a construction joint there about halfway up. For some reason, again, to me unknown, because I could not get the owner to respond. The owner would not allow the 2-lift method to be done. They wanted all 45 feet cast in one. The concrete in there was not. The steel was not terribly congested. I'll be honest with you, in the column. It wasn't a terrible congestion issue. Just the height issue was the problem. All right. mandating that kind of, plus the fact that the owner's spec said maximum slump of 6 inches. Now, 6-inch concrete, 6-inch slump concrete can still be kind of stiff. So what do you, what you can see where this happened, right, where this struggled with, and this is what they got. The first one they went down in, when they got down in, and now we're looking at, there's the bottom of the column. They got the first truck in there. Actually, the first truck came out at only about 4.5 inches slump. So contractor admitted, they probably shouldn't have used that, but they did. And they stopped after and the other issue that they came into play with it was contractor had vibrating whips with only 35 foot of length. All right, so 35 feet of length, you can do the math here, guys. Even construction guys can, right? Okay, that leaves us about 10 feet short of being able to reach the bottom of that. They couldn't put external vibrators on it because they were concerned about vibrating the forms at the bottom. They were renting the forms, and I think correct me if I'm wrong here, Mike, but I think most of your companies will invalidate what's going on if you use external vibrators on their stuff. I think Perry was the folks that was providing that. So they took it out after the first truck, and they got concrete vibrators stuck in there. They got down there and couldn't get them out. Okay, so what do you do when that happens? You run another one down to loosen it up, right? And then what happens when that one gets stuck? All right, they got 2 stuck, and they managed to get it out with the third one, and then came up with, again, then being contractors, they came up with a very unique situation. Mike, you've probably faced this before, but how do you do that now? You got more columns you got to fit, you got to put down here. They actually took a piece of PVC pipe, all right, cut it a little over halfway around, slid that all the way down, and then ran your vibrator down inside that to protect it from getting caught, okay? And they were able then to slide it down and do the rest of the forms that way. So a way to come out, but this cost them some money. Obviously, this cost them some money. Why? Because, in my opinion, because the owner did not want to, there was a little bit of culpability on both sides. I think the contractor admits now they probably could have done things a little differently. But the real issue was the DOT, in this case, did not want to budge on 6 inches, did not want to budge on the length of even though it's out in the middle of nowhere. Why would a construction joint bother anybody? You're out in the middle of the desert. There's not a person living within 20 miles of that bridge. But that's what the DOT wanted to do. So it's a people business. You got to work with that. A couple of other examples that I'll get out of your hair here and get on the way. High-rise building. Mike already showed this one anyway. This is right on ASU's campus. Designer, again, not considering design costs. Mike already covered this one twice, I think, but we have this exact same issue. Just to show you, it shows up just about everywhere. 22-story building on one side, 15 stories on the other. It's the issue was column size adjustment. When the building was originally designed, it was going to have about this is kind of unique building for those of you this is a senior living facility with healthcare attachment right on Arizona State campus. All right, so the design specifically to say, come retire here and you can use all the university facilities as part of your operations. And oh, by the way, our development office will get a hold of you shortly after you get here. And it has worked. We've already had a major donation come from people that live there. But anyway, back to constructability. All right, during the design, priority is always often given to you structural engineers. We got to maintain costs. We got to maintain. We want those columns to be just as small as possible because a column is not rentable space, right? I got to have floor space, and I can't rent a column to you. I can rent floor space. So we want to maximize that, which means we're going to make those columns the same size, as small as we possibly can. And in this particular case, it was a CM job. The first column design came out. We had 32 different column sizes, not nearly as bad as Mike was explaining, but 32 is 32. And the contractor sat down with that and got it down to 14. And they didn't share how much money it saved, and I didn't bother asking. But significant on those, because most, again, structural engineers in the room, Have any classes on formwork and formwork cost and those kind of things? Of course not, all right? It's just, it's F prime C and what's that? Phi MN, right? That's the thing. Phi MN bigger than MU. That's what you got to do. You got to make sure, capacity is bigger than actual, right? That's the whole rule. If you're done that, you go to sleep at night and you're just fine. You don't worry about those other things. Well, we need to think about those other things, all right? So that's number 3, the last one, and I'll get out of your hair. This is right around campus. This one is in particular, I show this to our students every year. This is one we did where there were problems there that we didn't fix as a contractor, and we should have, and I'll blame the contractor for that. Nice long sidewalk there. You see that road going down? It's about 12, 15 feet wide as a service road right next to our building on campus, and you can see that things that we just didn't fix. All right, so we all know concrete shrinks when it cures, right? And it shrinks so, and if we know that cracks will occur due to shrinkage. That's the primary thing, right? Shrinkage plus restraint gives us cracks. And that's why we tool joints. That's why we saw cut joints. We want to create that weakened plane, right? So that's the whole reason why we do it, is so that we don't have cracks and we have nice lines, all right? Okay, so look down that sidewalk, ladies and gentlemen, and you will see what? Because I don't think that our team understood that on this job. So you look at that driveway, and there's 3 bollards in the middle there to keep traffic from going down there. And in each case, we've drilled out formed out a 2-foot hole. That driveway is going to try to shrink primarily in its longitudinal length. All right. So where's the weakened plane there, guys? Weakened plane would be right between all those 3 bollard holes, wouldn't it? Because that's where the material is gone. We're asking the concrete to shrink around each one of those holes. Wouldn't it make sense to put a joint there? I would think. Okay, that would be right there, and then put your joints anywhere else you want, and space them out at your 20 feet, whatever your methodology is, engineers, for figuring that out. There's crack number 1, there's crack number 2, there's crack number 3. I've highlighted them with some black magic marker, and there's crack number 4. All right, perfect. And the worst part about it is, you go back and look at crack number 2 there's a joint about 1.5 feet away from it. Why couldn't we have put that joint right between them? Wouldn't that make more sense? And hide all those cracks. Now, the building's not falling down, and the cracks aren't terribly displaced, so no big issue, right? But how easy would it have been to do it differently, okay? That's the point. Here's another example on that same structure. This is a big generator pad. You guys probably seen that. We have this huge generator sitting outside our building just in case the power goes out, so we can keep the air conditioning on, so we can keep teaching students. How nice is that for the professors, okay? And as you see, it sits on an isolation pad just for the vibration when it runs, all right, which makes sense. So I'm looking at, this is a driveway in front of it there for loading, unloading into the building. And so I'm looking at the jointing pattern on this when I first got constructed, and I say, okay, let's see, how did we connect the jointing pattern on the driveway at all with that pad going around it, okay? And you look at the right-hand edge of that, all right, and you see, really nicely done. On the one end, they lined up the joints with the pad, all right? Perfect, that's what it should be, right? Nicely done, there's no cracks noted on anywhere around that corner. That's the way it should be done. You would think it would make sense to do it on the other side too, wouldn't it? No? Okay, so you look at the other side of that, and what do you see? Shouldn't we have a joint right there? Wouldn't that make sense? No, it's too easy. Look where we asked the concrete just shrink around that corner for us, guys. It doesn't, okay? So we get a crack. Okay, look at the other end of the pad, and you got the same problem. Okay, that's the other side of that pad, and there we put a joint again, 12 inches away. We have a joint within 12 inches of it. Why wouldn't we have lined that up and then solve that crack to it in? So things like that, and I get way too animated about these kind of issues, but it's just things like that why are we not talking about this, and why do we not have better collaboration? And that goes back to collaboration Mike was talking about. How do we do that? We need to have, and I can't really say exactly who took place on this one, but I can throw a lot of rocks at the contractor on this, because I know the graduates that I had working on this project. And they should have caught that. But we didn't that day. So how do we teach constructability? I think the only way to improve that constructability is to reach down right now at the early age and start it while everyone is still in school. All right? And there's 5 examples from our program, some of which involve some students in the room right now. I'm talking to you, Noah, Brandon, all right? You recognize that one, right? Okay? And where these are coming out of our classes, where we take our students. The middle picture on the top. Any architects in the room? Any architects? No? Oh, they won't raise their hand now. I got them. All right. That's our construction students at a major architecture firm as part of their introduction class, learning what architects do for a living. And oh, by the way, they take them down there for an hour and a half. They take a tour of the plant. I want to know what architects do. That's what I want our construction students to do in the first class, all right? And then I've talked to the faculty, or talked to the folks down there that give their presentation. I said, does the architecture school ever bring their students down here? Nah. We've never seen an architecture class in our building, is what they've told me. This is the largest architecture firm in the state of Arizona. Never had an architecture firm come down, an architecture class come down. And I'm saying, we got something wrong with that system if we can't do that. Okay? And for you structural engineers in the room, go back and ask your structural engineering universities if you're close, do you take your students anywhere out of the building? I'm going to be willing to say they probably don't. All right? And I think that is a big problem. Every one of those things there are, you're seeing some ACI field training going on. We're doing ACI field training, and that is an industry professor in the purple shirt standing up there looking down at watching that guy, all right? The one on the right is a mechanical contractor talking about mechanical systems to one of our students. We took our student club out to learn about formwork. The one on the bottom right is another class opportunity. Again, we're taking in this case, I've got freshman students in the program being taught by an alum that works for a ready-mix plant that's showing this is what we do. Mike talked about you get the students out to and ask the craft questions. I do just that. I get the guys out and I say, hey, I sit back and I don't talk at all during these tours, during these field trips. I let the craft guys, I let the field guys say, this is how we do it. That one on the bottom right, those were four or five superintendents. Mike, I apologize. That was Suntech. That was not not Baker, but same concept. I mean, they had 4 or 5 superintendents out there just absolutely loving talking to our students about how to set wall forms, all right? And that is how we teach constructability. That's all we got. More industry interaction. That's what we need. And I'll say this right now. I bashed the engineering and the architecture programs. There are challenges there. There's a cultural challenge there that we have to solve. They don't get, engineering especially, they don't get rewarded for taking students to the field. They get rewarded for doing research and publishing papers. That's what you guys get rewarded for. I understand that. How do we solve that problem? How can we help that problem? Because we end up with we end up with a faculty coming into our programs with 0 construction experience. And how do we solve that? How can they can't bring constructability to the table if they have never done it. One of the things ACI could change here, I think would help, would be, how about if the foundation created a model like AGC does? AGC actually has a foundation set up to say, we will pay for a faculty to go work in the summer for a school, at an industry company like Baker. We'll pay 1/3 of their cost. School will pay 1/3 of the cost, and let the university, work out a system there. They have those kind of things available. That would help our constructability by getting it started now at the early ages for those engineers, because right now we don't have that available. It's not all the students' fault, but it's just, and then it has to be encouraged on the students. We mandate it in the construction programs. students have to take it on themselves in architecture and engineering to make it happen. And I think too often there's not enough encouragement there. And I'm done.